Hello everyone, I am Mai A Shaaban, a PhD student in Mohamed bin Zayed University of Artificial Intelligence. I am presenting a paper titled Fine-tuned Large Language Models for Symptom Recognition from Spanish Clinical Text. This paper explores the SympTEMIST challenge as part of BioCreative Conference 2023. The challenge has three subtasks. In this paper, we focus on the first subtask, which is symptom in ER. The research problem that we focus on in this paper is called the biomedical named entity recognition, or bio-NER. In this task, we are trying to extract meaningful entities that could help in predicting patient diagnosis. For example, symptoms, signs, and findings. These entities could be found in clinical textual data from electronic health records and medical reports. As I mentioned before, this paper explores the symptom text mining shared task, or SympTEMIST track, as part of the BioCreative 2023 conference. And here we are using large language models for this task. We are following two techniques to solve the problem. The first approach is fine-tuning large language models. We fine-tuned 6 large language models, including general domain ones and domain-specific ones. XLM Roberta Large and XLM Roberta Base are multilingual masked language models, both trained on a dataset of over 2 terabytes. However, they are different in the number of parameters. So XLM Roberta Large has more parameters than XLM Roberta Base. We also leverage BBS and BBES, which are both pre-trained on Spanish clinical data. However, BBS exclusively leverages biomedical resources, and BBES incorporates both biomedical and EHR data. Lastly, we leverage E5B and E5L, which again different in the number of parameters, and they are both advanced text embedding models trained through a contrastive approach using weak supervision. The second approach is called the majority voting. To mitigate risks associated with relying on a single model, we employ the majority voting technique, combining predictions of the 6 models to favor entity labels with the most frequent consensus across the ensemble. We explore the SympTEMIST dataset, which has 744 Spanish medical records. Each of them is uniquely identified by a file name. In each record, we have 5 features. The first one is the annotation ID, which uniquely identifies each text in that file. We also have the target label, symptom, start and end positions, and finally the corresponding text snippet. For tokenization, we use the SPACY tool and we follow the IOP tagging scheme. Finally, we split the data into 95% for training and 5% for validation. For testing, we received separate files with a total of 250 examples. During the experiment, we incorporated all training examples, including the 5% validation data for fine-tuning the models. For hyperparameters, we set a batch size of 4. We trained the models for 70 epochs. We employed a linear scheduler for the learning rate. For that, we use PyTorch and Hugging Face transformers. Coming to results. As you can see in the figure, there is a consistent upward trend in performance for the validation set as the number of epochs increased for all 6 models. This signifies that all models are learning and improving the ability to make accurate predictions. XLM Roberta Large, BBES, and BBS were the best performing models, and that's why they were chosen for evaluation on this set. Although validation data has a relatively smaller size than test data and may not fully capture the diversity inherent in the test data. In Table 1, we can see that the fine-tuned models predict few false positives, but they miss more true positive entities on test data. Also from the table, the majority voting resulted in a less accurate overall prediction, and this could be because it may average out correct predictions with incorrect ones. Finally, the observed results on test data indicate that domain-specific models on Spanish clinical data outperform general domain models. In conclusion, the accurate identification of symptoms in clinical reports is crucial for healthcare and biomedical natural language processing. These entities are foundational for extracting vital medical insights from extensive text data. Recognizing and categorizing these entities is key for advanced clinical decision support systems to assist healthcare professionals. Our study using domain-specific models fine-tuned with SympTEMIST data demonstrates the urgency for continued research and progress in this field, as these models outperform general domain ones when applied to Spanish clinical data. One of the potential future directions is that we can augment the large language models with diverse architectures that have undergone extensive fine-tuning using substantial or similar datasets. Finally, we can consider the weighted majority voting, and by that I mean we can assign higher weights to the best performing models and lower weights for the lowest performing models to avoid the problem of vote dilution. Last but not least, I would like to thank the co-authors, and this presentation was presented by me on behalf of all of them. Thank you.